Hello, my name is Hudson Nash, and my project is titled Microbial Fuel Cells for Environmental Monitoring 2 from last year's continuation project, in which I found that microbial fuel cells were capable of detecting atrazine trace organic herbicide at concentrations as low as 1 part per billion, and possibly even much lower. In my study, I compared microbial fuel cells fed with different substrates using electrochemical data to explore mediatorless microbial fuel cell-based water quality monitoring. Nearby water security crises of recent years, including lead contamination in Flint, Michigan, and frog mutation in the Midwestern United States, have clearly shown that the improvement of water quality monitoring systems is critical to maintaining public health and safety. Because contemporary techniques are incapable of continuous monitoring, the onset of disasters can be weeks or months prior to their detection, and therefore we can be very late on the draw when it comes to these large-scale catastrophes. The main advantage of microbial fuel cell-based biosensors is the augmented range of detectable contaminants due to the electrically automated biomonitoring. I attempted to dissect the electrical current generated by microbes in order to identify the sources from which the current originates. In order to dissect the electrical current, I used voltammetry. The leading hypothesis of this experiment was that mediatorless microbial fuel cell-based biosensors inoculated with microbial cultures feeding on different substrates would have discernibly different differential pulse and half-wave potentials. Over 350 voltammetry scans were executed in this project. The substrate fed to each microbial fuel cell was the categorical independent variable. The categorical independent variable was the basis for the statistical analysis. Prior to statistical analysis, data was arranged into two separate perspectives, one from the within cells among trials perspective and the other from the among cells within trials perspective. The within cells among trials perspective was used to check the among cells within trials perspective. This checking is done by comparing the significant difference yielded by a Holm-Bonferroni correction of the Mann-Whitney U-test. Because the within cells among trials perspective yielded 35% significant difference, while the among cells within trials perspective yielded only 24% significant difference, null hypothesis is accepted. Qualitative signal strength was used among scans in cyclic voltammetry to indicate the constancy among physical properties of media, including conductance and pH. The variance of the anodic or lower wave versus the cathodic or upper wave is an indicator of microbial shock during cyclic voltammetry. Scan rate was actually the primary culprit for similarity among scan results, even if they had different metabolic pathways in play or different organic substrates or even different kinetic properties of the electrolyte.